Good morning everyone. During our internship, we developed an electric vehicle dashboard using STM32. This is our team. I am Vijay PK and Satvik Sandesh Kumar. We made a team of 3. Our main objectives of our project was to monitor important vehicle parameters such as speed, battery level, motor, temperature, acceleration position and brake position in real time. We also implemented a basic advanced driver assistance system ADAS to detect the nearby obstacle using an ultrasonic sensors. Finally, we transmitted all the processor data through the UART to the virtual terminal and simulated the complete system using SimLab. Our project is an EV dashboard developed using STM32F103C8T6 Blue Pill microcontroller. We designed our dashboard to continuously monitor the display the real-time vehicle parameters. Since we did not have an actual electric vehicle, we used a potentiometer to simulate the return pedal, brake pedal and battery state of the charge and motor temperature. We also interpreted an SR04 ultrasonic sensor to detect the obstacle for ADAS feature. The processor vehicle data is transmitted through the UART and displayed on the virtual terminal. Finally, we tested and validated the complete system using SimLab without requiring physical hardware. During our internship program, 14-day internship, we learned the complete STM32 development process, starting from basic GPIO programming to developing a complete embedded system. In STM32, we learned STM32F103 architecture, ARM Cortex M3 processor, memory organization, GPIO, ADAS, UART timer, and their application in embedded and automotive system. And STM32 Cube ID, we learned how to create STM32 project. We learned how to create STM32 project with write embedded C code, compile program error and generate firmware files. STM32 Cube MX. We configured GPIO, ADAS, UART timer and clock setting using Cube MX, which automatically generates the installation code. And in GPIO configuration, we learned to configure the pin as input and output for controlling LEDs and reading the digital signal, and LED blinking. Our first assembly program was LED blinking, which helped us understand GPIO configuration and all function. And we learned it was embedded C. We learned embedded C programming and model programming. Y.C and .h files are used. In week 2, we learned timer, ADAS and UART communication. We learned how the timer generate accurate delays, and we learned how the ADAS converts the negative voltage into digital, and ultrasonic how they read the values. UART communication, how they transmit data, and in ultrasonic we learned how they transmit, how they measure distance. And interrupt, we learned how interrupt improve the real-time performance by allowing the CPU to respond immediately to event. And we dashboard development. Finally, we integrate all the with GPIO, ADAS, UART, timer, interrupt and ultrasonic sensor to develop a complete EV dashboard with the ADAS simulation. And we learned software and the tools used in our project. We learned STM32 Cube used for writing, compiling and debugging the STM32 program, generate executable binary files, or the binary file and what is the use of binary files. STM32 Cube MX configuration, how we manually generate HAL instance code automatically by configuring the GPU pins and clock configuration done in Cube. STM32 Cube MX. FixLim, what is the use of FixLim, and simulate STM32 Blue Pill board and tested complete EV dashboard without hardware. ARM GCC compare, you compare embedded C code into the machine code, generate execute firmware for STM32 What is we run virtual terminal display the UAT data in real time, user for debugging and monitoring the vehicle parameters, and programming language we learned embedded C, developed for STM32, implemented modular programming using .c and .h file. And these things are we learned. And just the GPU timer and ADC we learned on what is write pin 2, read pin 2, and toggle pin 2, and what is the use of prescaler by the microcontroller runs in 72 megahertz. That so speed we have to reduce that speed and to generate a timer to do, but for that we use PSC register, and what is the use of count register and AR registers, and how the ADAS converts the, and we gain these skills and in our internship program. For in the internship program, conclusion, we successfully developed an electric dashboard using STM32, and we learned a lot of things. Thank you. Next, Satvik will explaining the our project, final project in live demo.
Hello everyone, my name is Satvik, as fourth year Electronics and Communication Engineering student at PCT2. Today I am presenting my final internship project, real-time EV telemetry and ADAS dashboard. Here I am used STM32 and Pixim lab to simulate and Python dashboard to represent my output. Here Pixim lab, here in Pixim lab, I am using potentiometer to simulate the accelerometer pedal, brake pedal, and motor temperature. I am also using three edges R0 for ultrasonic sensor to simulate the front radar and side blind spot detection system. Here, ultrasonic sensor will measure the distance using the sound waves. It calculates the distance by emitting the sound waves, ultrasonic sound waves. In my updates the vehicle state every 10 milliseconds. The physical updates the vehicle state every 100 milliseconds. The UI digital formats data into a strict rejects compatible string and broadcast it over a serial port. This ensures the dashboard stays perfectly in sync and with the hardware without lagging. Most important part here is uh, normal driving and speed. It works on real time. Uh, Here I am used STM32 F103C8T6 blue pill microcontroller program using embedded C in using STM32 cube ID. Python based GUI running locally using a matplotlib to visualize live data. Bridge virtual bidirectional UART port operating at a baud rate of 1520. The hardware inputs analog inputs ADC and three potentiometers are connected to STM32 analog to digital converter pins. These simulate the accelerometer pedal, brake pedal, and motor temperature. Digital inputs are timers or GPU. Three HSR 0 for ultrasonic sensors simulate spatial awareness. The STM32 sends a trigger pulse and uses hardware timers to measure the echo return time, calculating the exact distance of the obstacles in the front, left, and right of the vehicle. The core brain of the project runs in the STM32 using strict non-blocking time architecture powered by hardware interrupts. Here there are LEDs which represent the red LED represent the front distance, front volume, and green LED represents the left distance, uh, like blind spot, and blue LED represents the right. Here we can see the start the demos by putting the binary variable, loading the binary variables, binary folders. So here we can see that put as potentiometer or accelerometer, brake, the source and temperature readings are taking, and in the week term we can see that speed 21 is showing 21 to showing now. As I decrease the distance of the front ultrasonic sensor, I will get the warnings. Here, a red light is turned on means collision is there. When the distance is reduces, the fault will go. As here, we can see that in the left, as it comes below near six near something value, mm, means green light will be turned on, and in the right, I make to normal condition. When it is when the blind spot is present right, the blue LED will turn on. As same thing here, also printed in here. Warning also printed here. And we turn. And it will transfer data in URT using VSP terminal. Like I here implemented using VSP terminal, VSPE. So it will be transferred to the dashboard. I will open terminal here and connect my dashboard. Yeah, now it is updated. When I increase the speed, increase the distance in the front, decrease the distance in the front, here the distance will be showed here. You can see here. See, it is giving warning where it's coming front distance is less. Same thing if I decrease the distance in the left means going to show. So it is showing here. Here showing 76 km. Same thing I will do in the right sensor too. No, it is only showing here. And it is showing the speed history also. You can see there here speed history and accelerometer and all everything is showing accelerometer. If I decrease the accelerometer, it will show the less value here. Same thing, 74%. If I apply the brake value will also showing here. Brake is applied. So it is showing alarm also showing. So it is my dashboard and I have implemented this. By this, I got a knowledge. Our team got a knowledge. Thank you. Thank you.